Welcome, everyone. Thank you for joining us for today's Alaska webinar. My name is Sarah. I'm the Communications Coordinator with Alaska Community Action on Toxics. And today we will be having a conversation about plastic pollution, chemical recycling technologies for advanced recycling, and plastics legislation in Alaska. Just a little bit about our work here at Alaska Community Action on Toxics. Here at ACAT, we're very interested in proactive state legislation that is addressing the plastics crisis that we're in addition to action at the national and international levels. We're currently working to ensure the negotiation of an international and legally binding treaty on plastics, and we will be participating in the next negotiation session in April in Ottawa. And on the state level, we are actively opposing House Bill 143, which is titled Advanced Recycling and Facilities. So advanced recycling, as you will hear later, is a false solution. These facilities are very inefficient and energy intensive and very dangerous. They generate a lot of hazardous waste while producing very small amounts of actually usable products. And the bill passed the House last week, so we want to urge everyone to contact your state senators to oppose this legislation. And of course, we're happy to share information about ways that you can engage with us in this work. Quickly, before I get started and introduce our amazing speakers we have, I want to note that CHE Alaska is a program of ACAT and Collaborative for Health and the Environment, and it's also part of CHE's broader international coalition of over 5,000 individuals across the globe. I also want to note that during the presentations, we'll have the chat box disabled, but if you have any questions, please feel free to send them in the Q&A box at the bottom of the screen. And after the presentations, we'll get to as many questions as we can. So we have our two amazing speakers joining us today. Presenting first is Dr. Eric Carmona. He's a scientist at the Helmholtz Center for Environmental Research, UFZ, who will be sharing findings from a recent study that he co-authored about chemical pollutants found in recycled plastics. And we're also joined by Alaska State Representative Andy Josephson, and he will be discussing plastics and related legislation here in Alaska. So thank you both so much for being here. And I think now I will pass it over to Dr. Carmona to start us off.
Thank you very much, Sarah, for the introduction. Looking forward to hear your questions, your discussions afterwards. Let me just start. Just with a brief introduction of myself. So I'm an environmental scientist with a background in toxicology and a PhD on chemistry. And since 2019, I'm working at as Sarah said, at the Helmholtz Center for Environmental Research in Germany, in Leipzig, with some collaborations at the University of Gothenburg in Sweden, and also teaching at the University of Goethe, Frankfurt, and in Aachen, also in Germany. But to start as an introduction, probably you would know this show, and I would like to start with some questions because I don't know, sorry, your background as well. So I tried, it's a bit scientific, this presentation, but I would like to know, what do you know about plastic? So Sarah also created a poll. So first, it will be, the first question is, in which century do we date the use of the first polymers that gave rise to today's plastics? So the options are A, 14th century after Christ, 16th century before Christ, 3rd century after Christ, or 19th century after Christ. So you can answer now, I think, in the poll. Right? Okay. So do we have the answers already? Yeah, okay, I cannot see them, but
it looks like most people put 19th century AC. We have a few that put 14th and 16th.
Okay, so I would say the answer is the 16th century after Christ, before Christ, sorry. The use of the polymer dates back from this century before Christ, when ancient Mesoamericans culture first processed natural rubber into solid objects. Ancient Mesoamericans obtained the raw material for making rubber objects from latex produced by the tree Castilla elastica. Yeah, so wow. Okay, not so many. Let's see the next question. Uh, yeah, so which company or companies developed the first vulcanization of the rubber, giving rise to today's plastics? Goodyear, Hancock, Michelin, or A and B are correct?
Okay, for this one, most people put Goodyear and a couple people put Michelin and A and B.
Okay, so the correct option is, okay, I cannot, yeah. So A and B are correct. So Goodyear in the US and Hancock in England developed the vulcanization of rubber. The hardening of the rubber and its increased resistance to cold in parallel. And so the plastics industry began with the development of the first thermosetting plastics by Bakeland in 1909. Bakeland produced the first synthetic polymer and also developed the plastic molding process. These early plastics were named bakelite, and yeah, after he discovered. Yeah, and I think it's a last question. So how much plastic was produced in 2022 worldwide? This is maybe a bit more difficult.
Okay, for this one, it's sort of split between 400 million tons and 910, a bit more on 910.
Okay, so the answer here is 400 millions of metric tons. So that's a lot of plastic that are produced in 2022, and every year we are increasing of the plastic production. So that's a big problem that we have, and we don't know what to do with that, basically. Yeah, as you can see here in this graph, let me maybe show you here. So we have a line that is increasing the production of plastics, and there are two different points in the 75 and in 2008 that the production of plastics was a bit lower, and that's caused by financial crisis. I still don't have the data from the crisis of the COVID, but I'm super curious what happened there. But because I have the feeling that even more plastic was used in that age. Well, in that year. Well, if we continue, the plastic that it's produced the most is the polypropylene that basically we are using the most for food boxes, for example, followed by low density polyethylene that are used for plastic bags and fibers for clothes, and the high density polyethylene that is in the polymer that we are using in our study. Yeah, so in total, 407 millions of metric tons at the end. So I would like that you, in an exercise, to just take a look in your room and identify a couple of objects that are made of plastic. So probably you will identify more than two and much more, because our phones, even sometimes acrylic windows, bottles, are made of plastics, but yeah, many other materials are made of plastics, even the clothes and the food boxes. So we have a very, we are invading by plastics. And if we check the packaging is where we produce more plastic for packaging, followed by constructions and other sectors, but textiles and consumer products. So we use for many things the plastics. And the problem is what is happening with that plastics later. So unfortunately, the plastics are arriving to nature, especially to aquatic environments, as we can see in that horrible pictures, for me at least. And the problem is that afterwards, that plastics arrive to the trophic chain, to the food chain. And that's a problem not only for environment, but also at the end for human health. And we are part of the ecosystems, and at the end, it's a problem for us, but basically we are not doing too much to change anything. And what's the problem, the environmental problem? So when it arrives to the water, especially to the sea, the oceans or the seas have different currents all around the globe, and all the plastics are moving. And we saw that different big masses of plastics that in a wrong wording, we call it the plastic of island. So there are two big ones, probably the biggest ones, between the California and I think it's Japan. So we have big ones. So we can see here the density that it arrives to even 100 kilograms of plastics per square kilometer. So that's a huge number of concentration of plastic. And also the problem that we have is that at the end, that plastics are around. They are around for long time. For example, plastic bottles are for almost 500 years around. Plastic bags, they are not, like if you compare, of course, with plastic bottles, they are 20 years or cigarettes. But strong foam, so these boxes that are used for food to take away, they almost take forever. Or the coffee cups that we have in almost in every cafe to take away, they stay for 30 years. So that's a lot, and the solution should be to avoid them, of course. But also we have other solutions. That it's the recycling. The recycling, it's a solution that everybody can do, apart from the avoiding the use of plastics and try to use more sustainable materials like glass, for example. But recycling is one of the solutions, and for that the plastics arrives to the treatment plants, and through mechanical and thermic processes, so we could create the call it pellets. And with that pellets, we can create new objects made of plastic. And this is based what we did in our study, that we analyzed that pellets that are creating new objects of plastics. This is the name of the paper. Who is interested? That all the data that I'm going to present here, it's on there. And So on this study, we took 29 samples from 13 different countries, where basically of high density polyethylene. So all of them were pellets that are recycled. But these samples were taken from these countries, where basically the rich countries are selling to that countries for recycle. That's a bit horrible, I would say. I would not be too much in detail about how we analyzed that. We used an extraction method of the pellets to just take, basically we took the plastic, and we do this extraction method to just extract the chemicals that we would like to analyze. And this is it's a kind of new method that we developed for these two different methods that I don't know if you see my mouse, but yeah, for the LC and the GC. But yeah, LC, it's liquid chromatography, high resolution mass spectrometry. So this is a technique that it's highly and used, and it's very sensitive for analyze organic chemicals. That's our case. In this case, we could analyze more than 600 compounds in target analysis. So that means we are looking for that compound. And well, almost 800, sorry, because we did it later 200 more retrospectively. So 800 compounds in total that we are looking for them. And then non-target screening, it's okay, we analyzed and we look for all the chemicals that are in a range of masses. And then we look for them in different libraries. But yeah, also we used gas chromatography, mass spectrometry. So basically the chemicals that are more volatiles, we can analyze with this machine, and almost a bit more than 150 compounds we were analyzing. We developed a semi-automatic race workflow to analyze to calculate the concentrations with different quality checks, so we can confirm that the concentrations that we were measuring were the correct ones. And this was easy, but for the gas chromatography, we used a commercial software that it's, I would say, super slow. It's good, of course, but it's super slow, and it's for us a nightmare to analyze that data. And for the non-target screening, we used a very good commercial software called Compound Discoverer with millions of different compounds in the library. Yeah, and the results. So probably this is more interesting. In our samples, in our 2019 samples, we detect at least in one sample, in the different samples, 492 chemicals. We could quantify them. So 162 of them in our target list that we found were pesticides and biocides, followed by pharmaceuticals and industrial chemicals and so on. But that we found the most pesticides or pharmaceuticals doesn't mean that they are in the highest concentration. So if we see the high, I cannot change my slide. No. If we check the groups in the highest concentration, industrial chemicals, rubber additives, and fragrances and UV filters are the ones found in the highest concentration. That's something that we expect. Because most of the chemicals, most of the plastics have this kind of compound, so that's good that we found. So we can say the rest of the chemicals that we can found, yeah, we are sure that they were the chemicals and not others. But yeah, then we found repellents in a high concentration and pharmaceuticals and yeah, many others. So that's the most worrying part. So first, if we zoom in into the different compounds. So this first chemical with this ugly name, the N-ethyl autolyl sulfonamide, it's an industrial compound that we found in all the samples with high concentration. And of course, we don't know what is that compound. So we went to different labs with our database that we checked what compound is that, and yeah, that's an additive for the high density polyethylene. So that was normal, and nope, sorry. Yeah, it's normal, and that we found it, and we could say after seeing that that's the peak of the analysis that show us the machine when we analyzed, so we can confirm that that's the compound and not other one. But yeah, the first compounds, the first chemicals that we found are chemicals that we typically can see in different in plastics, including UV filters. UV filters are used to protect plastics and for that to not degrade the plastic that much easy. But then we found as a fifth, as the highest fifth chemical concentration was a pharmaceutical, the gabapentin lactam, and then an insecticide that is the sulfoton. So we found in 5 and 3 samples respectively with very high concentrations, almost 6,000 nanogram per liter. So that's quite a lot. So that means that plastics can act as a Trojan horse and then start releasing that chemicals into the environment. So that's something that we have to take care and yeah, investigate more and of course regulate that this is not happening. And if you are curious about where we can see the highest concentrations or the highest number of chemicals by country, Nigeria unfortunately has the plastic that we can see with the highest number of chemicals and the highest concentrations. But the lowest one is Tanzania with 143. That of course it's still a lot of chemicals. And with the non-target screening, so as I said, we cannot quantify that. So we don't know the concentration. So extractables and leachables. So these are chemicals that are coming from the plastic. 48, followed by pesticides and herbicides. Basically, we could find a lot of pesticides and herbicides. That means that many of the plastics that were recycled probably were packaging different pesticides. And yeah, and for the toxic effects, just briefly, this is something we still didn't publish and we will do soon, hopefully. So we can see that for growth inhibition test of algae, so if we increase the concentration of the plastics, of the exposure of plastics, so the algae were not growing that much. So that means that we were inhibiting the concentration. So that's a very bad thing, very toxic, because at the end, algae is one of the basic levels of trophic chains for the aquatic ecosystems. So if the aquatic ecosystem doesn't have food, they will migrate or even die. So that's very toxic. So because as we said at the first slide, most of the plastics arrive to the sea at the end, to the aquatic ecosystems. And yeah, I'm almost done. And yeah, I would like to just release some questions. So these are questions that we have to solve, the scientists, but also the society. So are these plastics suitable for food packaging? We are investigating that, and we will start some experiments soon. And yeah, I'm a bit worried that can also have harmful effects in human health, but of course we saw that there are effects in the environment. And this chemical that we saw that it's one of the main compounds of the high density polyethylene. It's a compound to monitor. It's a compound that it's toxic. This is something we don't know. And is there a way to remove chemicals and recycle plastics? There's something also some other colleagues are studying, are trying to investigate how to do it to improve at the end the recycling processes. But and the possible solutions, of course, as I said at the beginning, reducing of the consumption of plastics, it should be the first priority. But of course, probably as you identified many plastics probably in your room, it's a bit difficult at the moment to avoid these plastics because plastics are all around. And of course, they have very good uses, for example, for medical uses that are basic. And I don't say that we have to make disappear the plastics, but to reduce the consumption of plastics, especially for different uses. For example, as I said, for food packaging, for coffee or whatever, for example, to take away. So, and also the reaction of number of chemicals. We have many chemicals. I think they were listed even more than 13,000 different chemicals only for if only for one plastic, and that's a lot. And most of them, most of the chemicals are for the same they have the same properties, but at the end, the different companies are producing different chemicals because the patents do not pay the patents. So that's why they are creating more chemicals, and they have many toxic effects that we cannot know. That's why we said that it's necessary a regulation of the toxicity. I don't know the how is the regulation in the US, but in Europe we have the register of chemicals, and the toxicity at the moment was not mandatory to include the toxicity data of the chemical. It was not mandatory to include it in the register, and it will help a lot for us, for scientists, or for regulatory administrations to have that data. Only 1% at the European Register of Chemicals have that data. And of course, improve the recycle processes to remove all these toxic chemicals. I'm not against recycling. I think it's something that we have to work on it. It's the best solution at the moment that we have, more than even create new plastic. But this is something that we have to work to reduce the number of chemicals, or at least to remove all the chemicals that we have in the plastic, in the recycled plastics. Yeah, and that's all. I think it was a bit longer than I expected, Thank you very much for the invitation again. I saw that there are some questions. And thank you very much for your attention.
Thank you for that great presentation, Dr. Carmona, and thank you for walking us through the findings of your study, which I think is really essential for us to understand the real impacts of plastic waste on the environment and on people's health. So thank you for highlighting also the need for genuine solutions to this problem, and getting us started on the conversation of solutions and what we can actually do about this. And yes, just a reminder about the Q&A. We'll do the Q&A at the end of the webinar, but you can go ahead and enter your questions in the Q&A box at any time. So now with that, I will pass it over to our next speaker, Alaska State Representative Andy Josephson. Thank you so much for being here.
Thank you, everybody. I want to thank Dr. Carmona for an excellent presentation on the imperative of fixing and resolving, hopefully in a permanent sort of way, this plastics crisis. I'm Andy Josephson. I'm a state legislator from Alaska and represent a district in South Midtown Anchorage. I'm sitting in Juneau, the state capital, which is much closer to British Columbia. It's about an hour and a half by plane from Anchorage. And I've been asked to talk about some of the plastics legislation that we're looking at, good and bad, here in Juneau. So I have filed a bill called House Bill 354, which would eliminate largely the use of polystyrene foam in a restaurant in restaurants in the state. There are exceptions and carve-outs where undue hardship case can be made to our Department of Environmental Conservation. But essentially, both the state government and restaurants could no longer use polystyrenes except in prepared foods or in things like foam coolers and ice chests. They would be eliminated. Now, this effort follows both other states like California that have taken a lead on this. I think Maryland is a leader in this. But also recently, the Congress has introduced something called the Farewell to Foam Act. It's sponsored by Oregon Senators Wyden and Merkley. And it takes an aggressive posture as well toward eliminating polystyrenes and other foam products. I am in a tough climate here politically to move plastics legislation through. I've been in this job for 12 years, and I first started this effort in 2015. I filed a bill to ban plastic microbeads, The Congress passed something that I suspect strongly was a half measure and more cosmetic, which is not a good word because a lot of this includes a facial exfoliant cream. So it's literally and figuratively a cosmetic issue. But we had some hearings on the microbead bill, and then Congress sort of took over that effort, and I moved on to other matters. In 2017 and 18, and again in 19, I was in the majority and filed bills to either call for the ban of shopping bags, the plastic bags that everyone's familiar with, or to require the imposition of a fee. That followed a number of local governments in Alaska that had either banned them or imposed a fee. Interestingly, one of the lead places working on this was the Matanuska-Susitna Borough north of Anchorage, about 30 to 50 miles or more. It's a very conservative political place, but they had a very robust zero waste effort, particularly as it relates to plastic bags. And they were supportive of the effort. We, I think, twice were able to get bills out of committee. And that's a fairly big deal because it means that you've at least been able to make a case in committee A and gotten the support you need to get the majority of the committee to move the bill onto committee B. And I think, I know I did that once, I believe I did it twice. The bills were House Bill 264 and House Bill 81. Meanwhile, I am the state lead for the National Caucus of Environmental Legislators. And so I meet annually with them, and the discussion of plastics is front and center along with the climate crisis. And here's what NCEL writes about polystyrenes. They write that polystyrenes cause litter in communities, they harm wildlife, and has a highly toxic lifestyle. It is made from the carcinogen styrene and benzene and contains harmful polycyclic aromatic hydrocarbons, some of which can cause cancer. You know, as state lead and as someone who's passionate about this, even if the political climate is unfavorable to advancing bills, I want to be involved in keeping the dialogue going, keeping the discussion going. And we're told that as to plastic containers, for example, the one source cites that in 2022, plastic foam takeout containers ranked as the 7th most common item found around the world, with 463,269 collected in total. Well, of course, you can imagine how many aren't collected. The International Coastal Cleanup Volunteers collected over 8 million foam cups, plates, and takeout containers. And then lastly, the Ocean Conservancy in 2021 noted that a survey they conducted found that 22% of all US takeout and food delivery orders included plastic foam, foodware packaging. And the Conservancy estimates that at least 5.6 billion pieces of plastic foam are used by Americans each year, and at least 2.5 billion pieces of foam foodware are mistakenly put into recycling systems as something that is not easily recyclable. Sadly, I said there were good and bad pieces to what we're doing. Sadly, last week, a bill noted by this panel, and I think briefly by Ms. Banapur, passed, and it is an advanced recycling bill. The vote was, and this will sound particularly egregious, but it was something like 27 to 13. There was more support for an amendment that would have kept the definition of advanced recycling as a producer of solid waste, but that amendment failed relatively narrowly. The good news, I guess, is although the House has become more conservative, and so it supported this advanced recycling measure, which, by the way, good news again, this doesn't mean it's happening anytime. It means that the sort of skeletal structure to allow it to happen would go into law. But the other body, the state Senate, has become more progressive. And I'm confident that there, the senators will understand that the advanced recycling bill is sort of phony. It looks good. It sounds good. It's marketed well in that it's called advanced recycling. But in my view, it really is a permission slip for the oil industry to pretend that the plastics problem is resolved or resolving so that they can produce more and more plastics. So that's what I've been working on. We hope to get a hearing. The bill, however, on my bill, House Bill 354 on the banning of polystyrene, two committees of referral are Health and Social Services. I think that would be a tough committee to move a bill out of, although remotely possible. We hope to get at what I call a courtesy hearing and at least get a chance to get some media attention and educate my colleagues about it. It then goes to Labor and Commerce, which is a more favorable committee. So that's what's going on. By the way, we mirrored my bill, again, House Bill 354, based on ordinances in the city of Cordova in South Central Alaska, Bethel in Western Alaska, and also there's a third community if I can find it. Oh, Seward, also in South Central Alaska. So I think in the case of Seward and Cordova, which are not necessarily super progressive towns, but they rely on tourism, particularly Seward, and I think they know that that plastic is also an unsightly as well as a bad environmental practice. And I suspect those are factors. Bethel is less of a tourist town, and let's just assume that they were very wise in reaching the ordinance they did. So I'm very happy to be with you. If there's anything I can do to answer, I'd be happy to. You know, one thing I will say to those who are participating and are not Alaskans, one thing we suffer from, although it's a positive, is that Alaska is so vast and so much of it is so pristine that we run into a little bit of a tendency of believing that this won't harm us too bad because it's just decades away from being a suffocating problem. But I know that that's untrue. But Alaska on the environmental front suffers from this a lot. We have a lot of federal land. We have a lot of protected land. So there's a tendency from many Alaskans to believe that we need to just grow the economy without realizing we can do that and still be smart about plastics. I'd be happy to try to answer any questions.
Thank you, Representative Josephson, for your time and for your work on these issues, bringing up your Bill 354. These insights are really critical for the environment and for public health. And yeah, as we've discussed, real solutions to the plastics crisis looks like eliminating single-use plastics and banning microplastics and full transparency. So thank you for your insights on this. And I think now we can move into the Q&A part of the webinar. We have a lot of questions already. And I'll just go ahead and read some of them out. And whoever can answer. I see the first one is from Rachel Massey. She says, I'm interested to see that 6P phenoldiamine was on one of the top chemicals detected in your study, Dr. Carmona. And we know this is used in tire rubber. Do your results suggest it's being used in other rubber products as well?
Yeah, well, I just answered. We have another publication that we were analyzing the snow that we were taking from different streets. So basically, cars were passing by, and yeah, we were finding that compound. So basically, we could conclude that, of course, the car tires had this compound, call it 6-PPD. But also there will be soon another publication where we were leaching artificially different kinds of polymers. So we were I don't right now. I don't know which one was it, but we were analyzing PET, PE, and many others kind of plastics. And yeah, for some of them, we were finding this 6-PPD. This 6-PPD, for the ones that are not familiar, this compound is quite toxic, especially for fish. So there are different studies that 6-PPD, it's a chemical that will, it's super toxic for fish and will kill almost all of them when arrives to the aquatic environment.
Thank you for that response. And I think there's a follow-up question about whether rubber products are encompassed in the broader data on plastics.
Mm, you mean the one? It's the one with the total 400
Yes, I
million.
think you might have answered this one too. Yeah. Mhm.
Yes. Yeah, I said it's yeah, it's not my study. This is something I read. So I don't know which polymers were included, but in the study they said total production of plastic worldwide. So I don't know if also that polymers that Rachel Massey was writing, the rubber products are also included, but probably they will be included.
And then I have another question from an anonymous attendee about how chemicals in recycled plastics compare to original virgin plastics in terms of the amount of hazards and potential hazards.
Yeah. So in our study, we compared, we bought virgin plastic from a chemical company that they produced that plastic for us as a blank, so we can compare the chemicals that we found in the recycled plastics with the new plastic. So this is also that we use as a blank, and also we test the new plastic to the with a bioassay. So yeah, and it will be in the paper. Also, the other paper that I'm working on different study, we can see also different toxic effects with new plastics. So yeah, all plastics basically are toxic for the environment.
Thank you. And then I think this question is more directed for Representative Josephson about styrofoam bans. They say it's great to have bans, but as someone who lives in Maryland, we've had a ban in place for a few years now. How to enforce styrofoam bans, basically.
Well, that's a good question, and I offered her a quick written response. It's always easy to write a law of any. It could be a non-environmental law. We have a bill that would promote reading at ages K through 3. But you have to fund this to have reading instructors and tutors, right? Same concept. So the writing of the law is the easy part. Passage is challenging, and then it's enforcement. So I don't know, in Maryland, we don't have counties here. We're so vast that we don't have counties. We have some parts of the state that are totally unorganized. They have no city government, no borough government. This speaks to the size of Alaska. But one thing that people are reticent to do is to use what's called general funds or undesignated general funds, that basically a state's checkbook to pay for things. So they use fees essentially, and I'm not an expert on this, but I would think that you would want to choke it off at the supply source, which would be cheating restaurants or businesses, and perhaps impose fines. And I don't know if that would be done at the county level or the city level or the state level, but there has to be a deterrent, and then those fines could feed the enforcement mechanism. But there's nothing I just suggested that's rocket science, that's for sure.
Yeah, I don't know, Andy. Yeah, Mr. Representative. Yeah, I don't know if you are aware about the legislation also we have in Europe. Since yeah, I think it will be applied next year. So the plastics of only one use will be banned in all European Union. So the production is banned. So basically, of course, when they are already there in the market, of course they can use it, but companies cannot produce anymore. So that's the solution that in Europe they found. Of course, not the fines, but cutting their production. I don't know how much you can do in Alaska, of course, but just as an idea.
And that speaks to the national and you know, it reminds me, I used to teach constitutional law, so the Congress would have to explain why it has jurisdiction over that. And I think it could easily do that because of something called interstate commerce, right? So it should have jurisdiction over that, and that shouldn't be a problem.
Thank you for both of those responses. I see another question about potential non-plastic replacements for food packaging that's suitable for wide-scale application. It seems like plastic is a hard thing to get away from. It's everywhere.
Yes, and there are alternatives. I don't, you know, I suspect the alternatives have their own byproducts, but there are biodegradable and compostable products that would break down theoretically and would be acceptable under the bill. And it'd be interesting to see if Dr. Carmona agrees that there are alternatives and what concerns might be with those alternatives.
Yes, so these alternatives, this is one of the best alternatives that we have at the moment. Of course, for example, other uses like using glass, for example, at home or whatever. There are in other sectors that the plastic, it's not possible to change it. For example, in medical uses, and they are super useful and and of course avoid a lot of infectious disease, for example, in a operation room, for example. But yeah, in our normal daily life, if we are not medical doctors, we can avoid a lot. For example, here in Germany, we have in the cafes, we pay €1, for example, for a glass, for a cup that it's made of a hard plastic, but it's a reusable plastic. And then you can clean that. You can return that. They return you the €1, so it will be kind of $1 probably. And you return it to another cafe. It doesn't be necessary that it's in the same cafe. And they clean it, and then they can use it again for another coffee for another person. But yeah, these are also, and I think also that one, even though it's also a bioproduct, it's not made of 100% of plastic. It's a compostable plastic that it's for more than one use.
Thank you. I see a question for Dr. Carmona. Can you comment on some of the environmental and health consequences of chemicals conveyed in plastic pellets? You might have touched on this in your presentation.
Yes. Yeah, this is something I will study very soon. I will start this what will happen when plastics arrive to the organism in our health. There are already studies that we consume the amount of one credit card of plastic per week. So that's a lot. So imagine that we have, how many weeks are in a year? Well, 52, I think. 52 credit cards in a year we consume. And many of these chemicals have an effect in our hormone system, in our health system. There are some studies that also say that some of these chemicals can be potentially creating cancer, developing cancer, or some other allergic disease. So yeah, something still I cannot say what will happen in our organism, but yeah, we can see that the chemicals of the plastics can create a toxic effect in our organism, but also in the environmental health, especially in the aquatic organism that we can see that are quite toxic.
Thank you. One other question for Dr. Carmona, from Oriana. They're wondering if you can speak to recycling plastics and the end of life cycle, or how many cycles recycled materials can have. Specifically, marine plastics. Don't know if that, or whether this is a realistic approach for handling those materials.
Yeah, how many life cycles? So I understand that how many times you can use a plastic, right? Uh, so I can imagine, I'm not expert on that, sorry for that, but I can imagine on the kind of polymer, and also the number of additives that they add in the plastic to do it more resistant. Especially like for example, as I said, the UV chemicals or other chemicals that provide more durability. Yeah, so it will be depends a lot on the producer of the plastics, on the number of chemicals and the type of the polymer. So this is something I cannot say. There is not a specific answer.
Another question about fluoropolymer producers. From Beverly, do you have an insight on the claims from fluoropolymer producers that they're inert and not degradable and therefore not hazardous?
I think I'm hoping that Dr. Carmona will answer that.
I don't have an answer for that, actually.
We can get
I'm
back
so
to you on
sorry.
that, Beverly. Yeah. I saw there was one question that you answered, Representative Josephson, briefly about in addition to House Bill 354, do you envision additional state legislation to address the plastics crisis, maybe microplastics or other hazardous materials?
So the first thing that helps in this process is being in the majority because and I see there's some folks from Canada online. Of course, you all understand this process. I'm sure you go through the same thing, but things in the United States have become very tribal. And if you're on the team, quote unquote, then you can get hearings and you can advance legislation until such time as the most nervous member of your conference or caucus becomes weak-kneed, sort of. But it is possible to advance environmental legislation. I've done it a couple times, both on an oil spill bill and on a very significant wildlife management related bill. And I'm constantly sort of thinking about things through the prism of the environment. In fact, we're taking up later this morning a bill, resolution rather, on something called the National Petroleum Reserve Alaska, which is this vast area, mostly north of the Arctic Circle, and what should be done with it. It's a pristine, largely pristine area. But what I was saying in my response is that, if the stars are aligned and the Senate remains more progressive and the House returns to being more progressive, we could probably get some legislation through. There are a lot of Alaskans who enjoy the outdoors and are consumptive users, hunters and fishers. They work in tourism, et cetera, and they would see the benefit in these reforms as well. So, hopefully next January will be a great opportunity. We don't have a governor who has the power of veto who's very passionate about this. Now, in fairness, he does seem to care a lot about our renewable portfolio standard. That is, how much are we using renewable energy to heat our homes and run our electricity needs. And he does seem to care about climate, although he doesn't talk about it in quite that way. So there may be some opportunities coming up.
Thank you for that. I see a question from Otto about whether recycling is an effective solution and learning about plastic waste ending up in other countries, other continents. in Asia. A question for maybe either of you.
Yeah, I would say absolutely. Recycling it's better than creating new plastic. Uh, yeah. First of all, because we will not need to use new chemicals, and at the end, we will not have more waste. Uh, and also, creating new plastic, it will increase the effects for the global warming, because we'll need much more energy. Um, the thing I would say is that we need to improve the recycling processes to, well, not only, of course, to reduce the energy consumption, but also to try to remove all these dangerous chemicals. Then this is something that we are trying to use, to do, not to use, to do, especially with engineers. Still, we don't know. I hope we could have a solution in a near future for that. But of course, the best thing, as I always said, it would be to reduce the number of plastic consumption of plastic. And you said also in Canada, you send the plastic to China, and this is a common practice of the rich countries, in Canada, in the US, in Europe as well. We send to uh, third countries that are in developing, that they try to develop, and they recycle that plastics. And then the funny thing is that they sell to us the new products, and yeah, at the end we have the same problem.
Thank you. Maybe we have time for one final question. I see one from Leonora that says, history has shown limits to bans and prohibitions. What are some mechanisms we could think of to entice industries to innovate and accelerate the pace to reduce plastic use?
Well, again, this isn't necessarily my forte, but I have some thoughts on it. And one of the things I was just typing to Leonora is we have, for example, in Alaska, investors and banks like Goldman Sachs have said they will not invest anymore in oil extraction on the North Slope at the Arctic Ocean. That's where the state used to produce 20% of the country's daily oil needs. So there are significant oil fields way at the top of our state, which is, geez, like 900 miles from where I'm sitting right now, maybe 1,000 miles. And this is, this sort of movement has got the attention of the oil industry. So they now, in their own PowerPoints, have features talking about environment, science, and governance. They know that their shareholders are demanding action. It's a slow process, but really just in the last decade, we've seen some real serious change. The problem is, I'm thinking about the word feedstock. So the oil industry is looking at things like advanced recycling because they can use their feedstock, oil production, to go down a different lane and still make substantial revenue. So, it's about a carrot and stick approach. But I say never forget the stick, and that is legislation that commands and demands change. And then other enticements to get people, to get heavy industry where it needs to go. And this is for those on the panel, and you all know this, but this is a marathon, not a sprint, right? So we need to think about what 2040 will look like. And I think we can get there. The other thing that I believe very strongly is that our lives, not everywhere, not in Ukraine and not in the Middle East, but our lives collectively are too easy. They're just too simple. We don't tote water anymore. It's right at the tap, right? I think Eric probably can identify with some of this. It's okay to return to some of the habits of prior to the plastic revolution in the 50s, and we need to do that.
Thank you so much for your insights, and thank you to everyone who submitted a question. We had a lot of questions, so thank you to everyone for tuning in and taking part in this conversation. A recording of this webinar will be available on the ACAT website. And for anyone who registered for the original Zoom call, it'll also be sent to your email inboxes. So thank you again to our great panelists and for everyone for tuning in, and we will see you all next time.
Thank you, sir.
Thank you very much.